Hope the screen is visible to all of you. Let's start today's class. Okay. So, in the last class, we had stopped here in this slide where we were talking about how to get IP addresses. Okay. So, I had told and we had a discussion also, and some of you had doubts also about these two questions as to one is that how does a host get the IP address within its network, and how does a network get IP address for itself? So essentially, the two questions are that if you have a device which you want to connect to the internet, how does that device get that IP address? So basically, if there are some n number of devices belonging to a subnet, so how do these n devices get to know that which of the bits are basically adding to the address of that particular host? Okay, so how are they getting the host part, and how is the subnet part being received at the subnet side? So that means if you are connected to an ISP, how is that ISP getting that subnet address so that it can give you or give all the n devices what is the IP address? So for the ISP, it has to have a set of addresses, right? Only then it can give the addresses to the n devices that are getting connected to it. So how does the network get its IP address, which is basically the subnet, and how does a host get the IP address? Okay, so these are the two questions that we are going to answer. But first is we will try to understand that how does the host get an IP address. Okay, so suppose you are going to connect your device to the internet. So in your hostel room, you connected your device to Wi-Fi or you via an Ethernet cable. So now after that, in order to access the internet, you need to have some IP address. So how will your device get to know what is its IP address? Okay. Now, please remember this IP address is not there for each hardware. Like if you have a device, then that device does not have a corresponding IP address. IP address will be given to you by the network. Okay, and how it is being given? That is being given with the help of this protocol, which is known as Dynamic Host Configuration Protocol. Okay. Now, in the first item here, it has been written that it can be hard coded by sysadmin in config file. Okay, so this is the case in which you are probably trying to write a small code to just examine how it works, or you are trying to just use a device for a little bit of time, and then you just want to access how the internet is working, not for a very large scale utilization. Okay, hard coding anything is not good for any large scale utilization. So what do? We have to have something or some kind of a protocol which basically assigns the IP address to a particular device which is getting connected to the internet. Okay, now you can ask the question that why do we need such kind of a scenario? Okay, because if you see here, it is given that the device dynamically gets address from a server. Okay, so why is this dynamic? So the answer to this question is that see, we have only 32-bit IP address, right? So that means 2 power 32 is the number of combinations that we can have. Okay, so the address space is limited, but the number of user equipments or the number of devices that can get connected to the internet, and this is with respect to not a country but the whole world. Okay, so the number of devices that can get connected to the internet is much larger than the address space that can be there. So if we keep, or if we want to put, or if we hard code IP addresses, or if we assign IP addresses to each device and assign it permanently, so in that case we will be out of our address space. Also, one more thing is that you as a user or anybody is not always using the internet, right? If there is something that is using the internet always, then you can keep that IP address for that particular user as a permanent one. But if you are a client, if you remember the client server architecture, if you are a client or your device is a client, in that case, what will happen? That the client is going to use the internet, or the client is going to access the server only intermittently. It is not going to access it all the time. So for that reason, this plug and play kind of utilization came into picture. That means whenever internet is required by the device, it can get connected to it and get a dynamically assigned IP address to access the internet. Once the job is done, then it can disconnect itself from the internet and the IP address can be then used by some other device. Okay. So this is the concept that is being used here. Now we will study today about DHCP or Dynamic Host Configuration Protocol in detail. Alright. So what is the goal? As I already told, that the goal of DHCP is to dynamically obtain IP address for a host from the network server when it actually joins the network or tries to connect to the network. So what are the advantages that it gives? One is that it can renew its lease on address in use. Okay, so that means that if you are assigned an IP address for a given amount of time. Okay, now if you want to still browse for a little longer, so then you can renew your assignment of the IP address. That is one thing. Another is that um, it allows reuse of addresses. That's what I already explained earlier. That is, the device will hold the IP address only while it is connected to the internet. After that, it will release that address so that anyone else can use that. Okay. So it can be used to support mobile users who can join or leave network. Alright. So how does DHCP work? Alright. So a host basically starts with broadcasting a message which is known as DHCP discover. Okay, so DHCP discover message is broadcast by the host. Now you can see that the message optional is written here after the two steps. Now why it is optional, that I think you will understand when you see the diagram, and also you can think of it. Okay, so I will explain if you cannot understand why it is optional still. But just note this point that these two statements or these two steps are optional steps in certain cases. Okay, but we are going to read the entire one. So let us see how it works out. So first, the host will broadcast DHCP discover message. Then the DHCP server will respond with a DHCP offer message. So that means what is the server offering the host as IP address. Okay. So then the host, after receiving this offer from the server, it checks out that whether this offer is acceptable to it or not, and then it requests the IP address to the server. So basically, once the server gives the offer, then the host requests the particular IP address to the server. This message is known as the DHCP request message. Then once this is done, once the server receives the request message, then it sends the actual address to the host in the form of DHCP ACK message. Okay, so we'll see how it works out. So this is a DHCP client server scenario. So we have a DHCP server here with IP address 223.1.2.5. Okay. Now, so this is an information that typically the DHCP server will be co-located in router serving all subnets to which the router is attached. Okay. So what does it mean? So if in your subnet you are having a DHCP server attached, so then it will serve all the subnets which to which this particular or a particular router is attached. Okay, so essentially you will have a DHCP server in general which will be co-located in a router, and then it can serve all the subnets that are connected to that particular router. Now, as I was giving an example of you connecting to the Wi-Fi in your hostel room. Okay. So suppose there is a laptop which is trying to connect to an access point here, Wi-Fi access point. Okay. So this is the arriving DHCP client. This laptop which is trying to connect will become the arriving DHCP client, which needs an IP address to connect to the network. Now let us see the steps that will happen one by one. So first, as we know that the arriving client is the one that will initiate the connection, right? So the arriving client will first send a broadcast message. Broadcast message is essentially the message that is being sent to all hosts in the subnet which are connected to this particular client. Okay, so the broadcast message is being sent. What is a broadcast message? That is a DHCP discover message, which essentially means that is there any DHCP server. Okay, so once the DHCP server which is connected to the particular router gets this DHCP discover message. Okay, now let's just first look at this. So what does the DHCP discover message have, or what is the content of it? So for now, the arriving client, as you all know, it does not have a fixed IP address, right? So what is it given? It is given a very default address, that is 0.0.0.0. Okay, and this is the port. Okay. And as you remember that this DHCP discover message is a broadcast message. That means the message will be sent to all the hosts which are connected to the subnet, okay, or this particular network. So the broadcast, for broadcast address, the destination address is always given as 255.255.255.255. This is a broadcast address. That if you have to broadcast any message, then you will use this particular IP address, okay, with the port number given here. Okay. Now these are the addresses. So it is saying that this is the address that I have currently. I want an address, and this is the corresponding transaction ID. Alright. Now the server will send a DHCP offer. Okay, so what is it that's happening here? So first the client sent a DHCP discover message. After receiving a discover message, see, all other nodes or all other hosts which are receiving this DHCP discover message, they are not going to do anything because they are not the server, DHCP server. Only the DHCP server is going to act upon it. So once the DHCP server receives this discover message, then it basically responds by saying that, hi, I am the server. Okay, but how will it send this information? It still does not know the arriving client's IP address. For sending some data to somebody, you will need its IP address, right, or to a particular destination. So while sending back also, the server actually broadcasts the message that it is the server, DHCP server, and this is the range of IP address that I can give, or this is one IP address that is remaining with me. You can use that IP address. That's the offer message. Now, if we see in the datagram, what is the header content? So this is how the DHCP offer message looks like. Okay, so the source address would be 223.1.2.5. As you can see that this is the server's IP address and this is the corresponding port number. And the destination address, as I already told you, that in this case also the message will be broadcast, because the IP address of the client is still not known, right? So a broadcast message is being sent from the server side on port number 68. All right. Now this message has a lifetime. So apart from these two values, we do have a lifetime which is 3600 seconds. So YIADDR is basically telling that this is the IP address that the server has, which it can give to the arriving client. Okay, that is 223.1.2.4. Okay, and the transaction ID is the same because this is following the same transaction ID. Okay, now if you remember, in the last slide I had told you that the first two steps where the DHCP discover and DHCP offer messages are being communicated, those two steps are optional. Okay, now why are those two steps optional? Because if a client already remembers and wishes to reuse a previously allocated network address, then in that case you need not go through all these discover and offer messages, right? So that is why these two are optional. Okay, now let's get back to the way we were talking about. So after the offer message that is received at the client side, now the client has to respond. So what it does, it sends a DHCP request message. Okay, so since it needs the IP address, so it simply sends the request message saying that okay, I would like to use this IP address. Now this message is also a broadcast message. Okay. Now the question is, why is this message a broadcast message? So I would ask you people to think about it. Let me finish this. After that, I'll ask this question. Please think about it. Okay. Why should this message be broadcast to? So here, how would the header field look like? So the source address is, of course, 0.0.0, and the destination is 255.255, and so on, for the broadcast address. It is saying that okay, it can take this IP address, so that YIDADDR is 223.1.2.4. The transaction ID is now different, that is 655, because it is now sending a request message from the client side, and the lifetime is 3600 seconds. Once this is done, then the server, after receiving the request, it actually assigns the IP address to the client. How does it do that? It simply says that okay, you can have that IP address, and then broadcasts that message to. So what does it do? So it simply, so the source here is 223.1.2.5, port number is 67. Since it's broadcasting, destination address is 255.255.255, and port number is 68, and this is the IP address and the corresponding transaction ID and the lifetime of 3600 seconds. Okay. Now, once this acknowledgement is done, then the arriving client is now getting the particular IP address. Okay. Now, can I get back to my question as to why do the request and act, DHCP request and DHCP act messages are being broadcast? The other two we can understand, DHCP discover and DHCP offer messages, why they are being broadcast. But here, why are these two being broadcast? Can anybody tell this answer?
Ma'am, it could possibly be the case that the same IP address has been given to multiple clients in the DHCP offer packet. So, like if you broadcast it, maybe like so so the first client has sent the DHCP request, like he will broadcast it so that any subsequent client can make sure that he's not requesting with the same IP address.
So you are saying that, if I understand you correctly, you are saying that this server can broadcast this same IP address to a large number of clients. So the clients are broadcasting this address so that others can get to know that this guy also has been offered the same address. Is that so?
Yes, ma'am.
But if the server offers the same IP address to a large number of clients, that will only be the situation when the client, I mean, there are a large number of clients which are getting added to the network at the same time, and the server has only one IP address at that time, right?
Yes, ma'am.
Okay. But can there be any other scenario apart from what you are saying where it will be needed, that this is a special case you are telling? Okay. But can there be any other scenario as to why we would do the broadcast? Let us assume that this is the only. I mean, there's no such case like same address is being given to a large number of clients. Let us assume that there's only one IP address and this is the client which would be given probably this IP address. In that case, also, do we need to broadcast this IP address, this request and ACK message?
There might be two DHCP servers in a same network, and one of the server gives the IP address, and to tell the other DHCP server that I am using this IP address, we are broadcasting.
Still, it's a special scenario. You are saying that there are two DHCP servers.
Hello,
Ma'am, we
Yes,
know that
yes.
DHCP Discover and DHCP Offer are both optional. So let us take the
Hmm.
scenario where the client wishes to use his old IP address, the one he remembers.
Hmm. Hmm.
So in that case, to connect to the DHCP server, we'll need a broadcast because he's not sure where the server is.
Yes, yes. So, assume first think of this scenario. The first two were optional, okay? So, if the client wants to reuse the address, so in that case, how would it inform the server that it is trying to reuse that same address? Okay, so that is one thing. And in the second part, why it is still broadcast, the last one, that is DHCP ACK. Why is the DHCP ACK still a broadcast? Because by that time also the IP address has not been like formally given to the client yet. Okay, so that is why that is also a broadcast message. Okay. Okay, in some uh, parts or in some places, you might find in the internet some people actually teach it like this, that the DHCP request message, there will not be any broadcast, or in DHCP ACK, there will not be any broadcast. Okay, but please follow what Kurus and Ross, this 8th edition, is talking about. All right. Okay, now can we just use, or I mean, the question is, shall we just use this DHCP only for IP address allocation basically? Okay, so DHCP can be used for further more than IP address allocation. Okay, so what other information it can have? Okay, it can give the address of the first hop router for client. It can give name and IP address of the DNS server. We know that we would be requiring the DNS server's address, right? And it will also give the network mask, right? That means what is the subnet portion of the of the IP address, just to get to know that what is the host address. It will give you, once you know the subnet part, you know what's the host part also. Okay, so these are the information that DHCP can combine with it while giving the IP address to the host. Alright, so this is an example of how DHCP is going to work. Okay, so this is a router with DHCP server built into the router. Okay, so the router itself has a DHCP server built into it or connected to it. Okay, so you are trying to add a new device into this particular subnet. So layer wise, what is going to happen? Okay, please note where DHCP is lying in this layered structure. Okay, so now what's going to happen? We are going to connect a laptop which uses DHCP to get the IP address. Okay, The address of the first hop router will also be given with this, and the address of the DNS server will also be given by the DHCP server. Okay. Now, so layer by layer, from message, then segment, then you have your datagram, and then it becomes a frame, and then it has to be transferred. Okay, so these are Ethernet connections, that is wired connections. So it is transferred over the Ethernet medium. Now it has reached the DHCP server. Okay, now if you remember, the client, that means the host, which wants a which wants an IP address, will send first a broadcast message, right, to first discover that what is the server's IP address or who's the server. Okay, so that is why you have a Ethernet frame broadcast. Destination is of course FFFF on the LAN. Okay, and it is received at the router running the DHCP server. So this is how it happened. Okay, just now as I showed you. Now what will happen? The Ethernet will demultiplex that to the IP, and then layer by layer it gets demultiplexed. The entire frame that has been received then goes to the DHCP. Okay. Now, what does the DHCP server do when it gets this information? It formulates the DHCP acknowledgement containing the client's IP address. So this example is assuming that the first two parts which were given as optional, those two parts have not been considered here. Okay, just the last two parts, that is DHCP request and DHCP ACK. Okay, so first part was the DHCP request message, and this is the DHCP ACK message. So the DHCP server formulates the DHCP acknowledgement containing the client's IP address, the IP address of the first hop router for client, and the name and IP address of the DNS server. So this is how it works. This message will be transferred back, the ACK message will be transferred back to the host side, where the host will basically decapsulate the frame that has been received in order to finally get the message, DHCP message that has been sent by the server side. Okay, so that means it will receive the ACK packet, which is a reply from the server side. Okay. Once it receives this message, the client or this host will know what is its IP address, what is the name and IP address of the DNS server, and what is the IP address of its first hop router. Okay. All right. Now, I think this example is clear to all of you, but if you have any questions, of course you can ask. But I have a question before that. See, look at the transport layer protocol here. Okay, the transport layer protocol is UDP. Can anybody think of the reason why this is UDP here? So does that mean that DHCP works with UDP, or it can work with TCP? Or it is simply an example, which is why it is given just like that, UDP. Think of this answer. Okay, why is it UDP here? All right, so you have until end of the class to think of this answer. Okay, let me move further.
To broadcast, we can broadcast using TCP.
We cannot broadcast using TCP. That's what you're saying?
Yes, ma'am.
Why we cannot broadcast using TCP?
It's a connection-oriented, right? Connection-oriented protocol, so it can
So
only
for
have.
everybody, yes, for every connection, every host that you want to broadcast, you have to set up a connection. That's what you're saying, right? Hello.
The voice got broken. I couldn't hear the last.
Oh, no, I said that you are saying that because TCP is connection oriented, so if you want to broadcast some data using TCP, then that would mean that you have to set up a connection with every host present in the
Yes, ma'am.
network to send that message.
Yes,
So
ma'am.
that is why if we are broadcasting, it's better to use UDP. That's what you said, right?
Yes, yes, ma'am.
Okay. All right. Fine. Okay, so let's get to the next part then. So how do we get an IP address? First question was done using DHCP, the host gets an IP address. Okay. Now the second question comes, that is, how does the network get the subnet part of the IP address? Okay, that means we are saying that okay, host part is only some changes in the last bit, but what about the rest of the bigger chunk? Okay, the first order bits which are there. Okay, who decides that how much of this first order bits will be the subnet address, or which ones of them will be the subnet address? Okay, so that is that we are going to study here. Okay, so first, the answer to this question is that this subnet part of the IP address is allocated by the ISP's address space. Okay, so your internet service provider has been given a chunk of addresses. Okay, so out of this, the ISP basically decides that this block of address can be given to this organization, or the next block of address can be given to the next organization that the ISP is basically serving. Okay, so suppose this is the ISP's block. Okay, starts with 200.23.16.0 and 20. Excuse me, 20 is the subnet mask for the ISP. All right. Now, ISP can further, want to give the IP address to different organizations which are basically allocating, or which are basically paying the ISP to get access to internet, right? So what will the ISP do? ISP would try to give again some chunks of addresses. How would it do that? So up to 20 is subnet mask for ISP. So what does the ISP do? This is an example here. So for organization 0, it gave the subnet mask as 23. Like this, it gave out some 8 blocks for 8 organizations. Okay, so you can see 23.16, 200.23.16.0/23. So this is for some organization. Then again 200.23.18.0/23. This is again for another organization. Okay, so these chunks of blocks are now being given up by the ISP to different organizations. Now these different organizations will have different devices attached to them. Those devices will get IP addresses from this last part. Okay, the last order bits. By varying them, IP addresses can be allocated by each of the organizations to different devices which are attached to it. So if I have to give you an example, suppose you have BSNL for this Guwahati region, and you have our IIT, you have Guwahati University, you have certain hospitals, also big hospitals, etc. So those are some different organizations. Each organization has again n number of users with them. Okay, so you must have a chunk of address for each of these organizations so that they can further give the or the devices which belong to this organization can further be given IP addresses for using the internet. Okay, so maybe BSNL can give such blocks of addresses to these different organizations, which can further have different devices which will get any of these addresses belonging in the blocks. So another example of addressing is hierarchical addressing, or it is known as root aggregation. Okay, so see what happens here is you just divide the chunks or blocks of addresses, and then you give out those addresses to the organizations, different organizations. Now imagine the situation if some company takes over another company. Okay, so what will happen? You would think that if one company takes over another company, then you would have to change the IP address of everything from the beginning. Just imagine the amount of complexity that it can have in that case. So let us see an example here. So we have, so these are example names, okay? This fly-by-night ISP and ISPs are used. Just imagine that these are two different ISPs. Okay, now this guy, this fly-by-night ISP, this guy has 8 organizations associated to it, as was given in the last slide also. That simply in that way, the organizations have been given these chunks of addresses. Okay. Now, if this ISP has to inform its again nearby router that what kind of datagram or what kind of addresses does this ISP has. Okay, so in that case it can say that okay, I can if you send me anything with address beginning with 200.23.16.0/20. Okay, so in that case all the people or all the hosts which are associated with my ISP, they can probably get the address. Similarly, this ISP's RUS, if it has a subnet address of 199 subnet mask of 16, and its IP address is 199.31.0.0, which is the beginning address for this one. So it is simply broadcast, or sorry, it will simply inform the nearby router that okay, send me anything with addresses beginning with this particular IP address. Okay. Now, if there is a move that happens, so some guy, that is you want to change your ISP from BSNL to Airtel. Okay, so your organization, like for our institute also something like this has happened recently. So we moved from one ISP to another ISP. Okay, so this organization 1 in this example has moved from fly-by-night ISP to ISP's RUS. Okay. So how would the this ISP's RUS now inform the internet that it also has organization 1 with it? So it can, as of now, it has already informed that it can serve any hosts which have the addresses starting with this, that is 199.31.0.0. Okay, but now organization 1 belongs to or have the IP address 200.23.18.0/23. Okay, so this does not belong to this subnet, but this organization 1 has joined this ISP. Now you would say that okay, we will change the IP address related to this organization, but you are not changing the IP address of just the organization. You have to change the corresponding hosts, I mean all the sets of IP addresses, right? So that means the entire chunk changes. So that again is a cumbersome process. So what we can do, let's see what can be done. So the ISP now simply, so it's a very simple answer. If somebody just comes and you are saying that okay, it will not work, you just say that okay, then I will also say that apart from what my address was, please add the other address also. Okay, so that's what basically ISP, this ISP RUS that is doing. So instead of just saying the first chunk of address that it had, that is 199.31.0.0, it also says that whatever the address space of the organization 1 is, that is 200.23.18.0/23. It also sends this information that it can or anything which can be sent with these two addresses it can serve. Okay, so with this what happens, so here if you see it was a more generalized one, that is 200.23.16.0, whereas here it is a better match for organization 1 because you are simply saying the first address of this organization 1 itself, that is 200.23.18.0/23. Okay, so this kind of addressing which gives more specific roots to a particular organization, and it is known as hierarchical addressing. Okay. All right. Now, last words on IP addressing. So, how does an ISP get the block of addresses? Okay. So, what we have learned by now, that the ISP gets some block of addresses and it gives out that chunk of information, or sorry, the chunk of addresses to the different organizations which are attached to it. These chunk of addresses which are given out to these organizations, then the last bits of those will basically tell that how many number of IP addresses can be given to the devices that get connected via these organizations, right? So now the question that arises is, how do these ISPs get these block of addresses? We have a large number of ISPs throughout the world. Okay? So who gives the chunk of addresses to the ISPs? So this is done by an association which is known as the ICANN, or Internet Corporation for Assigned Names and Numbers. You can check out their website. So this association basically allocates IP addresses through 5 regional registries. Okay, so this association basically has regional registries and local registries, just a hierarchical maintenance for the different IP address blocks which are being given out to different ISPs. Okay, so depending upon the content in these, and it basically gives out or allocates IP addresses to different ISPs. Now this ICANN not only gives this IP addresses, it also manages the DNS root zone, including the delegation of the individual TLD management. So if you think about it, this is basically one organization which is handling all the management of the internet. That means giving out the IP addresses, managing the DNS root and the TLD servers. Okay. All right. Now the question that comes, okay, that the IP address that we have been talking about is a 32-bit IP address, and as I already told that, this question I have already answered earlier in the class today. That 32-bit IP address is not enough for the billions and billions of devices which are there in the world at this point of time. Okay, so how can we overcome this limitation, and still we can use internet, and we do it without any issues. All right. So for this, we will study IPv6. Okay. But let's see, before IPv6, what else can help us? Okay. So let's see what else can help us. So for this, let's first see NAT, or network address translation. Okay, so NAT is a concept which basically helps all devices in a local network to share just one IPv4 address for the outside world. Okay, for example, see, when you have inside your institute in a particular department or something, you will see that the IP addresses that are being given can be like 10.0.0.1, or even 127, like we use we can have like 127.0.0 like that. Okay, but most of the institutes, if you have gone to any of your previous schools or anything, There also, most commonly, the hosts would be given this kind of IP addresses like 10.0.0, 10.1.1, like that. But that is like, that becomes very common, right? So also you know that IP address, for at least for a communication, IP address basically uniquely defines who the host is. The host is just for network layer communication, right? So if this happens, then mostly if all institutes use such kind of easy IP addresses for assigning to their host, so then there's no uniqueness in that case, right? So in order to avoid that, and also in order to overcome this limitation of IPv4 addresses, network address translation or NAT is used. Okay, so what does NAT do? Simply what we, some real life example if you take, okay, whatever happens inside our house is for us, the other world or the entire society should know that we are, or our house by a particular name or a person's name or something like that. Okay, so people, so if you have a particular house, people inside the house, they can be, given or associated with some names or anything. Okay, some nicknames. But the outside people, they will know that this person belongs to this Malhotra family or Kapoor family or something like that. Okay, Malhotra's house or Kapoor's house, like that. Nobody knows that what happens inside their house. So that's what is being, that concept is being used in NAT. Okay, so the outside world will know your organization or your particular subnet as one IP address, one IPv4 address. But all the other devices inside your subnet, they can be given any other IP address of your choice, making it a local network or a home network. Okay, so let's see what happens here. So if you have such a scenario, so this is the router, and this interface is given this IP address, that is 10.0.0.4, and all the devices which are associated in this subnet, they are given this IP address 10.0.0.1, 2, and 3. Okay, so this entire interface with this subnet, that forms a local network here. This router is the one which is basically the door to the outside world. Okay, so this interface and the subnet correspondingly, they form the local network. This is the left side here where the mouse is. That is the rest of the internet. So now for the rest of the internet, this router has an interface which basically connects it to the rest of the internet, and that interface is given an IPv4 address given by 138.76.29.7. Okay, now if there is data, packet that has to arrive to any one of the hosts here, the destination address for the rest of the internet is going to be just 138.76.29.7. They will not know which host within this router we are talking about, or sorry, within this router subnet we are talking about. Okay, they will think of all of it as just one address. Okay? But once it comes to this particular router, then it is here that we have to do some processing to find out that which is the exact destination among all of these associated nodes or hosts. Okay, so let us see how NAT works. Okay, so as I already mentioned that devices in the local network can have a private IP address space. Okay, we can start with 10.0.0, 172.16/12, etc. Okay, so what are the advantages that it gives? That you can have just one IP address for the entire set of devices which are connected to the particular router, and then it can change the addresses of host in the local network without notifying the outside world. So whatever happens inside your home is not known to the outside world. That was the example that I was giving you, right? So if you want to change anything in the local network, that's okay. That is not going to affect anything in the outside network with the outside network, because the router which is at the edge, that is the one that interface that connects it to the internet. Only that IP address is the one that affects or that is affected by what happens in the outside of or in the outside world. So in the local network, you can do anything. Also, of course, the ISP can be changed without changing the addresses of devices in the local network. The problem that we were having earlier for hierarchical, when we were looking at hierarchical routing. And yes, NAT is a very good protocol which is used for providing security. Okay, please remember this. It provides security. How? Because the devices inside the local network, they are not directly addressable by anybody outside the particular local address or local network. Okay, so for the outside world, they do not know what is happening in this local set of devices which are attached to the particular router. Okay, so that is why NAT is a very good way of providing security. Okay, now I just want to go to the diagram. Let me just go to the diagram 1 second. I'll explain this later. All right, so what is the or how does this router just match these whatever datagram or sorry whatever packet that arrives at the particular router, how does it send it to the correct destination address? So for this, a table is maintained which is known as NAT translation table. So this is the WAN side address, that is wide area network, the outside internet, that side address, and this is the LAN side address, that is local area network. So the host 10.0.0.1, it sends a datagram to an outside destination which is 128.119.40.186 at port 80. So this is the source and destination field here. This for the local network. So within the local network, of course, you know which is the source and what is the destination address. So now this goes here in the network address translation table. Then you put the information that correspondingly 10.0.0.1 wanted to send the information to this particular destination address. Okay. Now this information goes to the outside world, and there the source address will become 138.76.29.7 with a particular port address 5001. So here, and the destination address of course remains the same. So here what the NAT router does, it basically changes the datagram source address to the outside interface, right? And then updates the corresponding NAT translation table as you can see here. Now similarly, if some data arrives from outside the internet, okay, so of course the source is suppose 128.119.40.186, same as the destination that was there in the previous example. So this is the source address, and then of course the destination address will be just this interface's address, right? So destination address is 138.76.29.7. Now once this information arrives here, then again the NAT translation table will be searched to find out that what is the corresponding local host's address whose reply has basically come back. Okay, so that is what is going to be checked here, and then finally you can see here that the source address is of course the same, that is 128.119.40.186, but the destination address is changed to 10.0.0.1. Okay, so this is how network address translation basically works. Okay, so we The class time is over, so I will not go further into this now. But if you have any questions, you can ask me. Otherwise, I can stop the